Okay, did you notice on last night's homework, there were these problems 7, 8, and 9 that had the parentheses around them? I want to make sure that you understand what those kind really mean, like 8 within the parenthesis with the 3. Do you get, if I have, I'm not going to do 8 and 3, but let's say I had 5 and 4. This means 5, choose 4. To be able to handle today's stuff, you need to be able to at least take the parentheses and write it as a 5, choose 4. And then I hope your teacher last year taught you how to make this into factorials. 5 factorial over, does anybody remember how I finished this deal? Why is it 1 factorial though? 5 minus 4 factorial, good. And then an extra 4 factorial. You need that. It's something you learned last year. I know you haven't touched in a long time because nobody stops you on the street and says, hey, what's 5, choose 4? But that's how you do it. And you'd have 5 factorial over 5 minus 4 is 1 factorial, and 4 factorial. And 1 factorial just means 1, so that doesn't really do anything down there. So then I'm going to write it out. All over 4, 3, 2, 1. So then the 4, 3, 2, 1 cancels the 4, 3, 2, 1, and the answer is 5. Does that ring a bell? Do you remember how to do those? Because there's a couple of those on last night's homework that I may have had you skip, but you should do them now because that's important to know how to do. All right, so let's just do one more like that. Let's say that we had, there were 10 kids in the class, really, really small class, and I wanted to make groups of 2. It happens all the time. Teachers want to pair you up, right? Well, how many groups of 2 could I make? Well, that's this, 10, choose 2. Would everybody please set it up? You don't have to get the final answer for me. Just get it set up first. I don't just mean 10, choose 2. I mean set it up with the factorials. Mr. W, can you do this?
Yep. So 10 factorial.
Yep.
Over in parentheses 10 minus 2. Factorial.
Excellent. Excellent. Okay, and then 10 minus 2 turns out to be 8, so I can just kind of skip to that. And that means 10, 9, 8, 7, da, 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 da. Keep going forever, right? Over 8, 7, 6, 5, 4, 3, 2, 1 times 2 times 1 because of that. All right, so now I'm going to go back in through here and say what cancels? Oh, 8, 7, 6, 5, 4, 3, 2, 1 cancels that one. And then I'm left with 10 times 9 is 90 over 2. Half of 90 is 45. Raise your hand if you understood that. Okay, good. Any follow-up questions? Yes, sir. I skipped a bunch myself. Yeah, I'm allowing you to show. You have to show work. Just to clarify, I'm not saying you don't have to show work, but you do not have to write out all the numbers from 10 factorial. Absolutely not. You can write it out, and then, like I say, put a dot, dot, dot. See, I stopped at 7. You could have stopped at 8 if you wanted to. That'd be fine. Just have to write out the beginning of it so that I can see, and then put a dot, dot, dot so that I know that you know it keeps going. All right. So why do we care so much about that? Because imagine for a moment that the problem was expand this x plus y, which is really nice and easy, to the 29th. Do you want to make a Pascal's triangle that has 30 numbers across the bottom of it? Because then you'd have to do the one above it, which had 29 numbers in the bottom of Pascal's triangle. You know what I'm saying? So it would take forever to find out what the coefficients are that go in front, because you'd have to do the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. You remember what I'm talking about, right? And that works great when there's a small number like 4 things that you got to find the coefficients for. But what we're going to do for today is say, let's say I wanted this spot. If I wanted that spot's coefficient, I don't have to make a 30 line of the Pascal's triangle. I just have to put a something choose something right here. In this case, it is 29. It'll always be a 29. This one's coefficient is 29, choose something. This one's coefficient is 29, choose something. And this spot right here, I really wish it was as easy as it's 29, choose 3, but it's not. Because at the end, what we want is when we're all done, we get to the last line. Remember, there'd be 30 dashes, right? So let's do 1, 2, skip a few, and then I get to my last line here. Do you get, if it was, it'd be 29, choose 30? Do you get how that can't work? You can't have 29 things and choose 30 of them. That's impossible. If you had 29, C30, you can't do that. The bigger number's always got to be over here. It's like I have 29 people and I'm going to choose sets of 30 of them. Impossible. So my point is, it's not as simple as, oh, this is, you want the third term? Then it's 29, choose 3. But it is as simple as one less than that. 29, choose 2. This one would be 29, choose 1. This spot right here would be 29, choose 0. Can you do that? Yes. You can choose 0 things from a group. If I have 29 of you, and I want to choose a group of 0 of you, I can do that. I can choose nobody. That's something you can do. Okay, so I know it'd be nice if this was just, oh, it's the third term, so you put a 3, but it's not. It's the third term, so you're going to put a 2. Another way to think of it is, remember me saying that sometimes we start with 0 in sequences? You know, U sub 0, and then U sub 1, and then U sub 2. 0, 1, 2. All right, so again, let's say you had a problem like this. A plus B, and it's to the 191. And I want to know what's the second term. Well, don't even bother to do the first term, but here's the second term. Third, dot, 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 dot. I want to know the second term. Figure it out. You won't have to make a gigantor Pascal's triangle to figure out the coefficient. You'll have one of these guys. The A's, you'll figure out how many A's there are and how many B's there are. I'll pause for a second for you to figure that one out. Okay, that's all the time it should have taken. Let's see. I know this is, you guys are new at this, but this would be 191, choose what? 0. This spot's 191, choose what? 1. There you go. And when it's all said and done, if you have 191 people and you want to choose one person at a time, there's 191 ways to do it, right? So this one, when you actually do the math on it, it's 191 factorial over 190 factorial, and then an extra 1 factorial. Everything cancels out except the 191, so the answer is 191. So it's 191 for your lead coefficient. And the A, well, I could start this. The A's would have been starting with 191, and the next one would be 190, because it goes down. And then the next one would have been A to the 189, and this would have been A to the 188. I think you get the idea. And then, again, all I care about is this term, but I'm showing you kind of the terms around it to help you understand the pattern. Now, how about the B? Well, the B would have been B to the 0 to start with, and then it's B to the first right there. So there's your answer. This actually comes out nice this time. 191, A to the 190th B. That is about as tough as they get for today. So I've already taught you in the first 10 minutes here everything you really need to know for today. I know if you haven't completely absorbed it yet, I wouldn't be too surprised because it usually takes longer than that. But that's the meat of what I'm trying to teach you for today. All right, so let's step back off one and just make sure you really understand expanding simple ones. Let's say I had x plus 2, and I want that to the third. Go ahead and make me the 4 terms. Of course, there's always one more than that. Make me the 4 terms in that answer. I'll pause for a second while you try that. Okay, hopefully you had 1, 2, 3, 4 spots. And this was x to the third. This was x to the second, x to the first, x to the 0. Raise your hand if you started right. Okay, good. Next, we go through and do the 2's. This is 2 to the 0, 2 to the 1, 2 to the second, and 2 to the third. All right, and then the last thing we need is the coefficients. Now, what you learned before was you could use Pascal's triangle, and I do a lot of times see this on the test. But I think once you find the way that I'm about to show you, you'll like it for the ones that have to make a really big Pascal's triangle. All right, well, that Pascal's triangle is enough. I can put one, here, I'll put them in blue here, 1 here, and a 3, and a 3, and a 1. And then these are all positive. Positive, positive, positive. There we go. Now, I asked you to clean them up, so I hope you did. If you would have given me an answer like this on your test, it's not simplified, so you'd have lost 5%. So let's simplify it. That's just a 1, and that's a 1, and 1s don't really need to be there. So x to the third plus 3 times 2 makes 6x squared plus, this is 4 times 3 makes 12x. And then this last one is, that's a 1, that's a 1. And then it's 2 to the third, which is really 8, plus 8. There's your final answer. Okay, a couple things that are going to come up today. One is the homework's going to say, and test questions could say, what is the constant term? When you see it, the answer, it's pretty easy to tell which of those 4 terms is the constant. But people get confused, like, what do you mean, the one that stays the same all the time, or what? It's just the one that's a whole number. That's the constant term. You get, of the 4 spots we had, only one of them is truly constant, because the other ones have variables. It's got a variable, that's got a variable, that's got a variable. All right, so the constant term, if you have one, you don't always have to have one. Some don't have a constant term because they have variables on every single thing. But usually it's if there's a number right here, then that means your very last term will be a constant. All right, one more like that. Just this one I actually want to have somebody else grade. I want to give you a freebie, the easy one right there. But this I'm going to have somebody else grade just to see if you get how to handle it when there's like a number in front of the variable. And what to do with is a negative. Hint, all it is that's a -1. As you put a -1 through each term, make sure you remember it's a -1, not a 1. And I'm going to have you do it to the 4th. And if you get stuck on 2 to the 4th, it's 16. All right, so give me the 5 terms for this answer. And I am going to have somebody else grade this one, so do it clean and neat and simplify it down so it's easy to read. I'll pause for a minute while you give this one a shot. This is called a binomial expansion. Okay, the students are currently moving to a different spot to grade a person's paper. And let's see if I can do it right. First of all, do you get what I did wrong right off the bat right there by saying 2x to the 4th? Yeah, there's parentheses. And therefore, that's not really 2x to the 4th. It's really what? 16x to the 4th, if you're going to do it. Multiply it all the way out. You can't just write 2x to the 4th. That's capriciously just sticking the 4 on only the x. The 4th power is going on both the 2 and the x. All right, so anyway, I'm going to finish this. 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and then 2x to the 0. I would just, the first line, it doesn't matter if it's messy because you're going to have to simplify it anyway. The next row, I'm going to go through and do my -1s. -1 to the 0, -1 to the 1st. Notice I'm using a -1 each time. Otherwise, you're not taking into account that there's a negative there. -1 to the 3rd, -1 to the 4th. You get when it's like an even power, then that's not going to be negative. It'll be positive. And then lastly, -1 to the 5th, and I did something tragically wrong. All right. 0, 1, 3, 4, 5. Okay, there we go. 2, and that's 3. At least I knew there was something wrong. 3 and 4. Okay, so now there's something else wrong. I'm missing something. numbers off Pascal's triangle. Now, if you want to do it with Pascal's, you can. But I just want to challenge you for a second because I just taught you this. This would be, if I do it with a choose thing, it would be 4 choose what? 0. This would be 4 choose 1 right here. This spot will be 4 choose 2. Just let me finish. And then this spot would be 4 choose 3 right here. And then the last spot right here. Get this guy out of here. Right there would be a 4 choose 4. Well, I happen to know that Pascal's triangle always has 1s on the outside. So that one's a 1 and that one's a 1. So it's not like that much work. You just have to figure out 3 little things. Okay? Now, since I happen to have Pascal's triangle written on my board over there, I'm going to be able to jump right to the answer. But this one, just so you know how it would have been done, 4 choose 1 could have been done as 4 choose 1, 4 factorial over 4 minus 1, which is 3 factorial, with an extra 1 factorial, which comes out to 4. So this should be a 1, this should be a 4, this should be a 6. This one comes out to 4, and this one comes out to 1 again. So now I'm going to clean it all up. 2 to the 4th is 16. Negative 1 to the 0 is positive 1. So this is 16x to the 4th. The next term, that's a 4. And then this is a 2 to the 3rd, which is an 8. And 8 times 4 is 32. Oh, and there's a negative 1 there. Negative 32 x to the 3rd. You get why there's so many little things, like it's so easy to make little mistakes. Now, if your person just has, like, let's say they had one little mistake, like you already saw me make earlier, don't butcher the whole thing and say it's all wrong. Just show them the one little thing they did wrong. Circle something if they did something wrong, because they're not going to want to know what they did wrong unless you tell them. Okay, so next up is this 6 here goes with this 2 squared, which is 4, and then this makes it positive 1. So that's 4 and 6 makes 24x squared. This term right here, we use a 4 and a 2 to the 1, which is 4 times 2, which is 8. That makes it negative 8, negative 8x. And then the last one is, that's all just 1. That's a 1. And that's a positive 1, so it's a 1. Does this one have a constant term? Yes, it does. And the constant term is 1. All right, cool. There it is in all its glory. Does anybody grading one where they had it perfectly right? All right, so you don't feel bad at home. There's only like 9 or 10 people in the room who are grading one that had it perfectly right. All right, and if you only made one little mistake, hey, you're like me. There's a lot of little mistakes to be made. Just got to be careful. We'll practice this and we'll get better. All right, head back to your spots. All right, so we're almost done with the lesson, and then you're going to get a bunch of time to work. Okay? So this is the part where I need to make sure you're ready for me to get into the homework. Better make that a smaller number. Otherwise, this will be just brutal. I would like to know what the coefficient is on the 3rd term. What's the coefficient on the 3rd term? Notice, I don't need you to find all 15 terms. I just asked you for the coefficient on the 3rd term. And I know nobody's going to use Pascal's triangle to figure that out. Unless anybody has worked out Pascal's triangle to so big it probably wouldn't even fit on paper anymore. I'll pause for a moment. Figure out the constant on the 3rd term. Okay, just to make sure you're not going too far astray, do you get that I'm asking you for the little something choose something thing, in which case it's always a 14, whatever this one is, on top, and then it's not 3 for the 3rd term. It's actually what? 2. So hopefully you're figuring out 14 choose 2. Raise your hand if you knew there was 14 choose 2. Okay, good. That's a good sign. Then what is 14 choose 2? It's 14 factorial over 14 minus 2, which is 12 factorial. and then an extra 2 factorial. So then that brings us down to 14 times 13 times 12 times 11, dot, 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 all over 12 times 11, dot, 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 2 factorial. And then the 12, 11, 10, 9, blah, 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 that'll all cancel. It's 14 times 13 divided by 2. 14 divided by the 2 could be done first, and that makes it 7. In other words, this could change into a 7 times a 2, and then I could cancel the 2. So then it's really 7 times 13. 91. Raise your hand if you had 91. Awesome. If you didn't have 91, but you see how I got it, then we're okay too. All right. Now that's not the whole term. That's just the coefficient on the term. You get the rest of the term. Wouldn't have been hard to find though. This would have been x to the 14. So this is x to the 13. This must be x to the 12. See how I did that? And then the other one, the negative 1. The negative 1 would start here at negative 1 to the 0. Then this is negative 1 to the second. This is negative 1 to the third, which means it is negative. So it's negative 91x to the 12th. That's the whole third term. All right. I'd like you to figure out the second to last term. The 13th, no, sorry, the 14th term, because remember there's actually 15 blanks when there's a 14 here. So if this was like the last one, period, then the one in front of that. Tell me that one. The second to last term. You got to use a little backwards thinking and say, well, what would the last term have been? That would have been where x was decreasing the whole time, so that would be x to the 0. And that makes, oh, then the one in front of that would be x to the 1 here. Raise your hand if you had an x in your answer. Okay, good. Then what this would be, I don't know if you noticed this pattern, but do you ever notice on the Pascal's triangle that the numbers kind of like repeat so that the second number and the second to last number are always the same? You know, when we go like 1, 3, 3, 1, that number and that number, the second number and the second to last number are the same. 1, 4, 6, 4, 1. That number and that number are the same. So, could have saved some time there. But if you did it this way, I totally respect it. You would have said 14, choose. This is going to be tough now. The very last one would be 14, choose 14. So this must be 14, choose 13. And then when you work it out, it ends up coming out to exactly the same thing, 91. Right? You don't get that? How about this? Did you get 14 to the 13? Or sorry, 14, choose 13? For that spot? Raise your hand if you did. Okay, good. I agree with that. And if you know the pattern that this is always going to be a 1 in front and a 1 at the end, and then these are always going to be the same, if this one's 91, that one's got to be 91. Oh, wait a minute. Oh, okay, thank you. This is, yes, this is the third term in here. 1, 2, 3 terms in. Thank you. It's not going to be 91. Okay, so sorry. 14, choose 13. I was just assuming that. I should have just done it. 14, choose 13 is not that hard because so much cancels. 14 minus 13 is 1 factorial with an extra 13 factorial. And, oh, it's 14. Sorry. How many had 14 and just thought I was crazy? Okay, good. You were right in this case. All right, so 14 is the constant. X to the 1, and then I got to do a negative 1 and see if whether that negative 1 turns out to cause this to be negative or not. So that negative 1 that goes through starts here at negative 1 to the 0, negative 1 to the second, negative 1 to the third, and by the end it should be up to negative 1 to the 13th. I'm not trusting myself anymore. Did you get the same thing as me? Okay, so then if it's negative 1 to the 13th, would you agree that's negative? And therefore it's negative 14 x to the 1. Raise your hand if you had that one, same as me. Okay, good. So then, that's a 12-minute warning here, so we have the rest of the time is going to be homework time. So let's get there. Everybody look at the homework with me. I'm going to pause for a second while we get there. Okay, so it starts right here. Now, this one says, I wish it just said, for the very first problem, I wish they gave you a really easy one. It just said, like, what's the third terms? What is the third term in this? Okay, but instead they said, the term that contains x to the 117. Well, it's not that hard. If I make a bunch of blanks, do you think I'm going to make 119 of them? No. But the first one's going to be x to the 118. The next one's going to be x to the 117. Oh, it's that one. So really, aren't they saying the second term? They're just trying to say the second term in a fancy way, because the second term would have an x to the 117 in it. So is that the whole second term? No, that's just part of it. You got to do this expansion. And this brings up a good reason why you won't want to just use Pascal's triangle, because Pascal's triangle would be immense. You'd never want to do it. So if this is truly the second term, then choose what should I use? 118, choose what? Choose 1, because the very first one is always 118, choose 0. So you are right. 118, choose 1. And that one works out really nice. I'm not going to do it. You have to do it because it's your homework. So the question was to write out the answer to the second term. There it is without its 2. I haven't dealt with the 2 yet, but you have to go back in and figure out what the 2 would be doing through this whole thing. Okay? That's the start of number 19. Number 21 confuses a lot of people, so let me clarify something on number 21. X to the negative 7th. I think a lot of people think that means that it's negative. It does not. What does x to the negative 7 mean again? 1 over x to the 7th. Excellent. They're saying that one of your terms, once you get it all simplified down, will be 1 over x to the 7. So if I do this expansion, if you need to, do every single term in it. There's 6 of them. But at the same time, do you get that as soon as you figure out the pattern, you can go, oh, I don't really need to find all the terms. I just got to find the one term that's going to have a 1 over x to the 7 in it. Here's another thing. I personally wouldn't write it this way. What is exactly? That's 1 over x cubed. So I would write this as 2x minus 1 over x cubed to the 5th. And I think that'll keep you from making mistakes. That gets one of our negatives out of there. And that there's so many negatives running around, it's likely you'll screw up your negatives otherwise. So I'm just saying, I hope you get that x to the negative 3rd is the same as 1 over x to the 3rd. That's what I'd put in right there. Then I think you'll figure out which of them, when you put it all together, which term has that in it, or x to the negative 7. If you come up with x to the negative 7 because you do it a different way, that's okay too. But one of the terms has that in it. And then they want to know what's the rest of that term. Obviously, that term has that in it, but it also has other stuff in it. Okay. Looking at number 22. How else could I have written this problem? Yep. Why is that better? Because it doesn't have a negative there to mess you up. All right, moving on. For this and the next page, you just need to understand the format of the question. It says find the coefficient. That's all you have to do. The answer is one of these kind of things. You know, 17, choose 2 or whatever, which you actually have to work out. But all they need is the coefficient. So the term that has the x to the 3rd in it, This problem, if I expand it out to all 9 spots, the key to today's being easier is you don't have to figure out all 9 terms. Just think ahead and go, which one of these would have an x to the 3rd in it? I right away go to, well, this guy is going to get just moved across at 2x to the 8th, to the 7th, to the 6th, to the 5th, to the 3rd. There we go. It'd be 2x to the 3rd. I missed one? Dang. I'm having counting issues today. 8, 7, 6, 5, 4, 3. That one. 2x to the 3rd. And now I realize that they have actually asked me to find the 1, 2, 3, 4, 5, 6th term. And then the coefficient on that, one of those guys, always has an 8. Here, you have to figure out the rest. Okay. Same thing here. Here's the question. If you want to make all 7 terms and find out which one's got that in it, go ahead. But I think there's smarter ways than doing all 7 terms. 2, 3, 4, 5, 6, 7. Same thing with this next one. That is in one of your 6 terms. You have to figure out which one. And once you know, oh, it's this one, then you only have to do that term. I'm not saying it's that one. Okay, and then it feels a little long, so I'm skipping number 7. Everybody cross off number 7. Now, this should not be super hard, but I know there's a few twists. I get that, so don't be too surprised if there's a couple that you go, dang, this one's complicated. I've talked you through a lot of the complications, but all right. Now, after this, we only have one topic left to teach you. It's called math induction. It's a way of proving things are true using this method called induction. So I teach you that for a couple days. Then we have some review. Then we take tests. It's going to be next week. All right. That's all I got for you for today.